All right, welcome. Hello, everyone. My name is David Malin. I'm on the computer science faculty here at Harvard and teach a few courses, most of them related to introductory computer science and higher level concepts that derive from that. The next couple of days are not so much, though, about building from the ground up as we might in a typical undergraduate course, but looking at computer science as it relates to business and to decision making really from the top down so that we can accommodate a range of backgrounds, as you'll soon see, both less technical and more technical, and also a number of goals that folks have. In fact, we thought we'd start off by taking a look at some of the demographics we have here, but first let's take a look at where we're headed. So today we have four blocks focused for the day. First up, we will focus on privacy, security, and society. And we'll do this by way of a couple of case studies of sorts. Very much in the news of late has been a certain company called Apple and a certain agency known as the FBI, as you might have read. And we'll use this as an opportunity to discuss exactly what some of the underlying issues there are, why it's interesting, what it means technologically, and use that to transition more generally to a discussion about security and making decisions thereon. Two, looking at encryption specifically. So we'll look a little more technically at what it means to actually scramble or encrypt information. And then we'll take a look at Dropbox, which is one of these very popular file sharing tools these days. You might use it or Box or SkyDrive or the more recent incarnation thereof and so forth. And we'll take a look at some of the underlying security and privacy implications there. We'll have a break and then we'll look at internet technologies in the latter half of this morning, trying to give you a better sense of how that thing works that many of you are connected to at the moment, certainly use most every day, and what the implications are there for performance, for hardware, for software, and any number of other attributes. Specifically trying to tease apart a whole bunch of acronyms that you might have seen or might even use but don't necessarily know what's going on underneath the hood. And we'll take a look, too, at the process of actually getting a company or getting an entity online on the web and what that actually means. Then we'll have a break for lunch. We'll come back and take a look at cloud computing and also designing server architectures more generally so that you'll walk out with a better understanding, hopefully, of this buzzword cloud computing, but what it actually means. And if you're trying to build a business or you're trying to expand a business, exactly what you need to know and what you need to do in order to handle increasing numbers of users online and what kind of decisions you have to make around that. And then in the last part of today, we'll take a look at web development specifically. We won't get our hands too dirty, but I thought it might be enlightening if we actually do get our hands a little dirty and take a look at something called HTML, CSS, and an actual server setup so that you'll create a little web page for yourself, even if you've done this before. But we'll talk about what the interesting ideas are underlying that and what actually is happening every time you go to Google Apps or Facebook or any number of other web-based tools. Tomorrow, meanwhile, we'll transition to a look in the morning at computational thinking, a fancy way of describing how a computer might think or a human versed in computing might think. A little more methodical, a little more algorithmic, as we might say. And we won't go too deeply into programming per se, but we'll focus on some of the tenets that you see in programming in computer science, abstraction, algorithms, and how you represent data and why that's actually interesting. We will take somewhat of a look at programming in the latter half of tomorrow morning. We'll get your hands a little dirty with that, but only so that we have some context for talking about some of the terms of art that an engineer or programmer might actually use, things you might hear or see on a whiteboard when engineers are designing something. In the latter half of tomorrow, we'll take a look at what might be called technology stacks. In other words, most people today don't really sit down with an empty screen in front of them and start building some application or building some website. You stand on the shoulders of others using things called frameworks and libraries, many of them open source these days. So we'll give you a sense of what all that's about and how you go about designing software and choosing those ingredients. And then we'll conclude with a look at web programming specifically and some of the technologies related there too. Things like databases, open source or commercial APIs or application programming interfaces, and then one such language that you might use with that. So it'll be a mix of conceptual introductions, a mix of hands-on, and a mix of discussion throughout. But before we do that, let me give you an answer to a couple of the questions that everyone here was asked. How would you describe your comfort with technology? We have a bit of a range here. So 6 people said somewhat comfortable, 5 said very, and 2 said not very. So that should lend itself to some interesting discussions. And please, at any point, whether you are in the not very or very categories, do push back. If either I'm sort of assuming too much or speaking at too high of a level, do bring me back down. And conversely, if you'd like to get a little more into the weeds with some topic technically, by all means, push on that. And happy to answer down to zeros and ones if need be. Do you have any programming experience in any language? Just to calibrate, almost everyone has no prior programming experience, which is great. And even for those that do, we won't spend too much time actually teaching how to program, but rather just giving you a taste so that we can then move from there and talk at a higher level about why some of those concepts are interesting. This and more will all be available online. In fact, if there's one URL you want to keep open in a tab throughout today and tomorrow, you might want to go to this one here, and that's a copy of the slides. And any changes we make over the course of today or discussions that we annotate on the slides, they'll be there instantly if you just reload your browser. So I'll give you a moment to jot that down, and you'll then be able to see exactly what I see. But before we forge ahead, I thought it might be helpful, especially since we're an intimate group, just to get to know each other a little bit and perhaps say where you're from or what you do and what you're hoping to get out of today and tomorrow, ideally so that you might find one or more like-minded spirits or folks to talk to during break or lunch. And I'll jump us around somewhat randomly. Arwa, if you'd like to say hello first.
Good morning, everyone. My name is Arwa. I'm from Saudi Arabia. I work in my sector like banking, business, telecommunication. I'm actually planning to complete my studies in the future, maybe in computer. So that's
Okay, wonderful. Welcome. Andrew?
Yeah, hi everyone. I'm Andrew Joyner. So I work for a technology company, Red Hat, which is a big open source company. I have a business background, so as we get more versed into making solution-oriented investments, I just need to kind of know what people are talking about. So I lead our global partner operations. I've been doing that for about 5 years. So your overview is fantastic. I'm really looking to pick up all those pieces.
Wonderful. Glad to have you. Chris?
Good morning. My name is Chris Pratt. I work for a company called Suburban Facilities Resources. We do commercial facility services. It's a family business, so I do a lot of different projects. And right now I'm focused on technology initiatives and managing our IT staff. So I'm here to get a more high level and broad understanding of the types of things that the IT staff at our company is doing and familiar with, so I can help them sort of make decisions and move things forward.
Wonderful. Welcome aboard. Olivier, is it?
Yes, so I'm French, living in Switzerland, working for Swiss Solidarity Foundation. It's a humanitarian arm of the Swiss Broadcasting Corporation. So we're collecting money when there's a disaster and everything, and I'm teaching some strategies there. So I have to work on much more communication and marketing related digital projects, but also quite technological projects. So the idea for me is really to be able to take better decisions and being better informed about what I'm doing every day.
Wonderful. Welcome. And Roman or Roman, is it?
I'm from Germany. I work for a tech startup, and I'm responsible for the business development team. And in that team, we are a cross-functional team, so we work with engineers. And what I'm looking forward to is being able to communicate better with engineers, prioritize features, work with product owners, etc.
Wonderful. And Karina?
I'm Karina from Montreal, and I'm IT consultant. I'm under contract with La Place 05. Is the central daycare waiting list of province of Quebec. Sorry for my English. And I'm here to better understand what my programmer or supplier explained to me.
Uh-huh.
And this is why I'm to better talk in English after.
Wonderful. Well, if I ever speak too quickly, do slow me down, and
I
I'm happy to
understand
repeat.
it, but it's to talk. It's a little bit difficult to talk.
Sure. No worries. And Likisa, is it?
Yes, thank you. My name is Lekisa, and I'm from Ethiopia. I am living in a private learning institution, which is from high school to college, training people. I myself am a member of the fund governance board. So I'm always confused with IT. I agree sometimes. When I graduated in economics in the late 1980s, whatever you are really getting under your finger, those take us about 2-3 days. So where we are today, and how can we really get better as available softwares? effectively use it, and how to make decisions on ITs to get a little understanding.
Okay, wonderful. Welcome. Victoria?
I'm Victoria. I live in Czech Republic. I work for Hewlett Packard Enterprise, and even though it is an IT company, it's possible that in an IT company you can have no IT people. So I'm focused on business development, and whenever I go to a customer meeting, I have to take a technical person with me because when customer asks questions about the technical side of the story, because I'm focused on negotiations and business, they talk to each other, but then I have no understanding of what they're discussing. So I'd like to get a better understanding because I think it will help myself and with my relationship with the customers as well.
And that's a good point for me to chime in. I mean, there's only so much we'll be able to do in just 2 days, but among the goals I would hope is that after the next couple of days, at least more words will look familiar as you're poking around online, and you'll sort of have a better sense of what to Google or what words actually mean something and what might be fluffy marketing speak, so that over time you can sort of build up that comfort and hopefully displace the person that has to tag along each time. Ben?
My name is Ben Scotland. I'm a technology transaction attorney from Memphis, and I'm really here to just get a better understanding of what CTOs and engineers are talking about when we're teaming up. Typically just handling the legal side of structuring things or agreements. I just want to get deep in that background and technology side of things.
Wonderful. And Dan?
Hi, everybody. My name's Dan. I live local here. I'm from Andover. I work locally at a software company, Kronos Incorporated. I've been in software over 20 years and through marketing and business development type jobs. For the last 5 years, I've managed a team of technical cloud consultants in a pre-sales fashion. So I've picked up a lot of concepts on the way, and so I do have a lot of technical discussions that I can only take so far. Similar to Victoria, lots of times I get lost and need to pull in a technical person. So I'm just looking to string a lot of technology jargon together so I get a better understanding, so I can have more informed conversation.
Excellent. Well, ultimately, we can steer the next couple of days in any direction folks would like. We have a straw man for both today and tomorrow, but by all means, feel free to steer us either during session or during breaks or lunch if there's something you'd like to get off your chest. And let me emphasize, there really is no dumb question. And if you feel like your question is dumb, by all means, just ask me more quietly during break or lunch or the like. But rest assured, we seem to be in very good company, very mixed company here, both internationally and technically. So feel free to share as comfortably as you'd like. So why don't we take a look, again in this context of privacy, security, and society, at this particular case involving Apple and the FBI. And you might be generally familiar with this case. It's hard to escape mention of it these days. Out of curiosity, how many of you have iPhones? Almost everyone, and you have an Android phone. So fortunately, even though this is a little biased toward iPhones specifically, the reality is the Android operating system by Google has so many of the similar features to what Apple's doing. They simply happen to be in the spotlight right now, and they've been particularly on the cutting edge when it comes to actually locking down these devices more and more with each iteration of iOS, the operating system that actually runs on Apple's devices. So why don't we take a look here just to set the stage at what the actual issue is. So what's going on with Apple and the FBI to the extent that you're familiar with the issue?
FBI wants to get access to the data which is encrypted by Apple.
Exactly. So the FBI wants to get access to data that's encrypted. So first, step back. What does it mean for data to be encrypted? Just as a quick definition.
It's somehow secured that people do not have such easy access to it or cannot understand what stands behind it.
Yeah, exactly. So it's some way of obscuring information so that no one else can, in theory, access that information. And so you can just generally, casually think of it as scrambling. So if it's, say, an English word or an English paragraph, you might just jumble the words up so that someone might look at it and it sees nonsense, but hopefully there's a way to rearrange those letters. Now, in reality, it's much more secure than that, because someone who's simply diligent could unscramble the words with high probability and figure out what a sentence says. And in reality, at the end of the day, all of this is happening at a very low level, zeros and ones. And tomorrow morning, we'll talk about computational thinking and what it means for data to be implemented or represented with just zeros and ones. But for today's purposes, let's just assume that you have things like emails and photos and videos and all of that on an iPhone or an Android device, and somehow that data is ideally scrambled. And so there's a suspect in this particular case, San Bernardino, where they have the suspect's phone and they want to get data off of it. But in this case, Apple has essentially said no to some things and yes to other things. So they've said yes to a few things in a manner consistent with what a lot of US companies would do when subpoenaed or the like. They've provided, for instance, the authorities with the iCloud backup. So if unfamiliar, iCloud is this cloud-based, and we'll come back to cloud computing, this sort of nebulously defined cloud-based service where it just backs up your data. And it turns out that you can access data there unencrypted. So it's unscrambled when it's actually being backed up there, and so Apple's turned that over. But unfortunately, the suspect in question seems to have disabled automatic iCloud backup some weeks prior to the FBI obtaining this particular iPhone. So there's a few weeks of potential data that lives on the phone, but not in iCloud, and so the FBI wants to actually look at what's on that particular phone. Unfortunately, the phone, like many of ours here, is protected with a passcode. And how long are these passcodes typically, whether on your phone or in general? Yeah, so often 4 digits. They've started with newer versions of iOS to make these passcodes a little longer. And let's just kind of put that into perspective. So if it's a 4-digit passcode, that's pretty good, right? That's comparable to what many people have on their ATMs or their debit cards. What's the implication for security? Well, let's take a step back. If you have a 4-digit code, and let's start to ourselves even before tomorrow morning, think computationally. It's a 4-digit code. How would you, as a human off the street, not necessarily a technophile, characterize just how secure an iPhone is if it's using a 4-digit passcode, 0s through 9s? How do you begin to quantify the security of an iPhone then? 5? And what do you mean by 5?
This technology, it's easy to access trying from 1001.
Okay.
Yeah. I can try 111. If I try my computer so many times to get access, I'm very safe.
Ah, good. So already, if we've defined the problem scenario as this device is secure because it has a 4-digit passcode, an attack on that phone would simply be to try all possible numbers, right? You might just start 0000, and frighteningly, that is the default passcode on a lot of devices these days. In fact, as an aside, if you have any device that supports a wireless technology called Bluetooth, the default passcode very often is 0000, or maybe if it's a more secure device, 00000, one additional 0. So when in doubt, if you need to get into some device, start there. But of course, if the iPhone shakes or whatnot and says, nope, that's not it, what number might you try after 0000? 1111, 2222, 7777, that's yours? Okay. So you might just brute force, as a computer scientist says, try all possible values. So that, let's steer back to the original question. How secure is an iPhone? Someone off the street might say very secure, or not very secure, or medium secure, but that's kind of meaningless. It'd be nice if we could ascribe something more quantitative, even if it's numbers. We don't need fancy math, but just some numerical estimate of qualification of the security. So if you've got a 4-digit passcode, can we begin to ascribe some kind of numeric rating to it? How secure is it? Yeah, so 1 out of 10,000. Where do you get the 10,000 from? Yeah, exactly. If you've got a 4-digit code, you can have 0000, or you can have 9999 maximally, and so that's 10,000 possibilities. So that seems pretty big, and it would certainly take a human quite some time to try all of those codes. And so suppose I, during lunch, swiped one of your iPhones and you have a 4-digit code. If I had enough time, maybe I could type in 0000, and then it shakes and says no, 0001, 0002, 003, and maybe I can do 1 per second, so that's 10,000 seconds. So how long would it take me in the end to actually get to decrypting or hacking into someone's iPhone, given these numbers? And we'll play with a few perhaps here. Let me go ahead and pull up overkill of a calculator. So if it's 10,000 seconds, there's 60 seconds in a minute, and there's 60 minutes in an hour, so it's like 2.7 hours. So I'd have to miss the afternoon sessions if I started during lunch, but it would only take me 2.7 hours to try getting into your iPhone. Now, you might be familiar with mechanisms that Apple, and soon probably other companies, use to defend against this. This does not seem or feel very secure anymore. And we'll come back in just a bit to do one more introduction, unless you feel omitted. What can we do to make this more secure? 10,000 feels like a lot, but 2.7 hours does not really feel like that long.
Doesn't it get locked after 3 attempts or something like that?
Maybe it does. In fact, hopefully not 3, because even I goof on my passcode 3 or more times. So there's typically some threshold, and I believe in iOS's case the default is actually 10, but similarly, similarly reasonable. So what does that mean? So what happens after 10 tries or whatever number of tries?
It gets locked.
Yeah, so the phone maybe locks itself down.
Time delay.
Time delay. What do you mean by time delay?
It'll lock the phone for 5 minutes, and after 5 minutes, you can try again.
All right, but that doesn't feel like it's solving the problem, right? Can't I just come back 5 minutes later and continue hacking on it?
Yes.
Okay.
But after you try again, it goes to 10 minutes.
Ah.
It keeps expanding.
So the thing increases, but
Yeah, exactly. So let's suppose it's not 1 per second, but it takes me for 10,000 codes, instead of times 1 second for each, it's actually not even 60 seconds, it's 5 minutes. So now this is the total amount of time I need in order to hack into a phone. And again, there's 60 seconds in a minute and 60 minutes in an hour. So now we're up to 833 hours. And if we want to see this precisely, now we're talking about 34 days. So it's going to take an adversary without sleep 34 days now to hack into your iPhone if there is this 5-minute delay. But it's not even just 5 minutes. As Kareem said, what happens after the next
After you try again
misattempt?
5 more times, it then gives you a 10-minute delay.
A 10-minute delay. And I'm not sure what it is after that, but maybe it's 20 minutes, maybe it's 40 minutes. And if it is, that's actually an example of a fairly common technique in computing known as exponential backoff, where this exponentiation usually means you double something again and again, so that it starts out being not so significant, but once you start doubling from 2 to 4 to 8 to 16 to 32 to 64, the gaps really start to widen, and so it might take a month or a year or a lifetime to actually get into that device. Now, there's other mechanisms still. Time is a good thing because, in general, this is a common security technique. You can't necessarily stop the bad guys, but you can slow them down. And because there are finite resources in life, like living, you can eventually push out the threat so far that even though, sure, the adversary might get really lucky and try 7777 on your phone and get the answer right, the probability of that is incredibly low. And so generally security is a function not of absolute protection, but of probabilistic protection. You're just pretty sure that you're safe and it's from some kind of attack. But that might not be really good enough, right? So what more could you do, and what more does Apple do, if people have enabled this, if an adversary or a bad guy tries to get in more than 10 times, besides inserting a delay? What would be a stronger measure of defense that might make you sleep better at night? Erase the data, yeah. So in fact, that's a very common technique where, much like the old movies, like this message will self-destruct in 10 seconds, very commonly will devices, iPhones among them, just wipe themselves, delete themselves after 10 incorrect attempts. So is this a good thing or a bad thing? Now let's sort of put on more of the product manager's hat. What's good about this? Why is this a positive feature? No access to your information. So now, not only have you slowed the adversary down, if you do have those artificial time delays, but you've also ensured that if he or she screws up 10 times, now the window of opportunity is just gone. They've only had 10 attempts. And the probability of getting the answer correct out of 10 attempts when there's 10,000 possibilities is 1 out of 1,000. So 10 divided by 10,000, 1 over 1,000. But even that's not all that good. So we'll come back to making me feel better about that probability, because it actually feels somewhat high. It's 0.1%. What's bad about this feature, though?
It's bad if the phone is in your hands.
Yeah, what do you mean my hands?
Like, if you didn't lose it and you're just trying to get into your phone.
Yeah, so what if there has been no compromise? You're just kind of distracted, you're an idiot, you forget your password, and so it's not that unreasonable, especially if you don't log into your phone that often or you're distracted while doing it. Maybe you yourself mistype your code 11 times, and now, damn it, you've just wiped your own device. So this, too, is kind of a theme in computing and computer science of trade-offs. There really is rarely a right answer. There's simply a more preferable or a less costly answer. And in this case, there's a trade-off. One, our data is a little more secure if it gets into the hands of some adversary, but I can shoot myself in the foot by wiping accidentally my own data if I don't actually get that passcode right within the first 10 times. So what's the push? How do we fix that? Do we throw the feature out altogether if we're Apple and say this feels bad because we're going to have, if we have one irate customer, this is not a situation we want to invite?
we encrypted and we recovered the code somehow, I don't know, by Apple or whatever, so we get access back to the information.
Can you elaborate? Okay, so maybe we don't do this wiping thing, which feels a little overly dramatic. Why don't we just keep the data encrypted? Well, so in this case, Apple already does keep the data encrypted. And what's keeping the adversary from seeing your encrypted data is, unfortunately, that passcode. So the passcode effectively unlocks the data so that while it's scrambled if you're just holding the phone, as soon as you log in with that passcode, it's unscrambled and the user can see it. So it is already encrypted. But if we want to avoid wiping the data, but we somehow want to have a good answer on the customer support line if the absent-minded or forgetful user has accidentally wiped his or her phone because they mistyped the password 11 times, what solution could we offer? How else could we solve that problem now? Yeah.
Customer service check who you are. Maybe send you an email or text you temporary password.
Okay, so that's good. So maybe without resorting to wiping, we could have some out-of-band mechanism for solving this problem. And by out-of-band, I mean you don't interact just with the phone. Maybe you grab someone else's phone or an email, and you talk to customer service, and maybe they ask you the usual questions of, well, what's your name? What's your birth date? What are the last 4 digits of your social security number or country ID? And what's good about that? Well, of course, with high probability, it lets you and only you into your phone because maybe they send a temporary passcode. And this does not exist in Apple's case, but maybe they do send you a temporary passcode. You get in, and you're back on your way. But what's the downside of this solution? Yeah, if someone steals your identity, and frankly, it's not all that hard, especially when so many companies ask the same questions. What's your name? What's your address? What are the last 4 digits of your social security number? What was your favorite pet? What was your favorite parent? Or whatever the questions might be. And in fact, as an aside, I've noticed, having just the other day filled out questions like these, the questions, in a reasonable effort to become a little less well-known, are getting increasingly personal. And as soon as you start giving this tidbit of information that might indeed be a secret to this company, and to this company, and to this company, and to this company, it's not going to be long before some company aggregates this kind of information. And so you've told little simple secrets, like your best friend growing up, to all of these individual companies. And soon enough, you have an attack known as social engineering, whereby someone just masquerades as you on the phone or spoofs your email address and somehow gets into the phone. So I'm not liking that. It's a possible solution, but let's suppose I'm not liking that. Let's go back to the issue at hand where phone is encrypted and we've not enabled some kind of self-destruct mechanism, but I have enabled some self-destruct mechanism, but I nonetheless want to appease a customer who accidentally wipes his or her phone. How else could we solve that problem? Make a backup. And indeed, this is how Apple happens to do this. One of the motivations of iCloud is exactly this, not only convenience and resting assured that all of your photos and everything are backed up, but in this case, because if your individual device, whether it's an iPad or iPhone or iPod, is lost or stolen or accidentally or deliberately wiped, at least all of your data is somewhere else. And you can just go buy or borrow another iPhone. You can restore from backup, so to speak, from iCloud, and you're back up and running. Now, there's a trade-off there. Potentially, Apple now has access to all of that same data, and we can come back to that sometime. But at least now, we've solved the problem in a different way. And if you kind of visualize this storyline in your mind's eye, you can perhaps see that every time we solve a problem, kind of like covering up a leak in a hose, some other problem springs up elsewhere. We're really just pushing the problem somewhere else. And in the case of the adversary, with the time delays, really what we're doing is we're not keeping the adversary out. We're just like raising the bar over which he or she has to jump in order to actually get access to our data. So anytime henceforth you go to a website or you read some white paper or some CTO or CSO tells you, oh, our systems are secure, like it's baloney. Like there's nothing to be meant by our systems are secure other than we take industry standard probabilistic measures to keep people away from your servers or away from your data. Now, the Apple situation has gotten kind of interesting because they've been asked to do something that's not quite as simple as turn over the adversary's data. They've already done that from iCloud. But now the FBI wants to get into this phone, and they believe that it does in fact have the self-destruct mechanism built in after 10 attempts. And I believe that's because they looked at the backups and realized this feature seems to be enabled. And I assume they don't want to necessarily try and waste 1 out of their 10 attempts to confirm or deny this feature. And they also Unfortunately, and this is sort of the irony of it all, the county where this fellow worked actually owned and was paying for special software, device management software, that had it been installed on their employee's phone. So the phone in question is actually state property or county property that was being used by an employee. Had they installed in advance this device management software, they could have, with a simple click on a PC or Mac, unlocked this phone trivially. But unfortunately, they didn't have that software actually installed. So there are yet other ways to address this kind of issue. It doesn't have to be a black box in your employee's pocket, but they didn't. And so now we're stuck with a situation with an encrypted iPhone that will literally will figuratively self-destruct after 10 incorrect attempts, and the FBI wants to get data off of that phone. So let's take a look at what Tim Cook has announced to the world and taken this bold stand. If you've not read it, let me go ahead and do this. If you'd like either on your computer to go to this URL here, or I can grab for you some paper copies. Why don't we just take 2 minutes, if you would, and read the actual letter that Tim Cook wrote to Apple's customers, and we'll see if we can't then tease apart what it actually means. And so I've circled a few things in this, but let's see if we can't distill what's actually being said here and where the real interesting stuff is hidden. So for instance, on the paragraph starting, under the San Bernardino case, the paragraph starting, "We have great respect for," Tim Cook's last sentence is this: "They have asked us to build a back door to the iPhone." And this is a commonly used phrase, back door to something. What does this actually mean, as best you can tell, or from what you've read here or elsewhere? They want to be able to hack it, and what does that mean? Like, what is a backdoor? Yeah, so it's an alternate entry point. I mean, much like an actual house where you have a front door and sometimes a back door where you're supposed to come in the front door and maybe not so much the back door unless you belong there. Apple, the FBI is asking for a figurative back door, another way of getting into the phone that isn't simply a human finger touching the code and getting in the usual way. They want to somehow slurp the data off, maybe with a cable, maybe wirelessly, or they want to somehow be able to input the code perhaps to the phone without just using a raw human finger. So they allude to in the next paragraph, the FBI wants us to make a new version of the iPhone operating system, circumventing several important security features. So why is the FBI asking Apple to make a new operating system? That seems to be kind of besides the point, no? Why do you think they might be saying that? How is this the solution to the problem? Yeah. Exactly. The version of iOS, the operating system that's running on the phone currently, has all of the security measures that we were discussing earlier. For instance, the time delay, potentially the self-destruct mechanism, all of which are particularly bad. And so the data is on there encrypted, and as best we can tell, Apple somehow stores data separate from the underlying operation of the phone, the operating system. And so it would seem to be possible to install a new operating system on the phone without touching the user's data. In fact, if any of you have ever updated Mac OS or Windows, I mean, it would be, hopefully, it's supposed to go this way, hopefully you've been able to update your operating system from an older version to a newer version without starting over, without deleting all of your files. Now, some of you have probably had the experience where that does not go according to plan, but in theory, this should be possible. Update the operating system, but do not delete or touch the actual data. So the FBI is proposing that Apple create an operating system that doesn't have these kinds of defense mechanisms, install it onto the phone so that they can get access to the data. Now, how is that possible? I mean, wouldn't the suspect himself, who's now deceased, have to install that software for the FBI? What is the FBI counting on here?
Could you push it down somehow? I mean, because that was my question. How do you install it if you can't log into it?
Yeah, exactly. So you would seem to have kind of a chicken and the egg problem here, whereby you would think to update the software, you need to log into the phone. But to log into the phone, you need to update the software so as to avoid these defense mechanisms. So let's just reason backwards. So not necessarily being a programmer at Apple, what must be the case? If the FBI thinks it can do this, what must be the case logically? Like, what is the answer to that question? It must be possible to do, presumably, somehow. So how might you do it? Right, all you are is a user with an iPhone, maybe a Mac or PC, maybe a cable. maybe a network connection. Like, how might the FBI be assuming Apple can do this?
Maybe through automatic updates.
Yeah, so very much in vogue these days is automatic updates, where an Android phone, an iPhone, Windows phone, whatnot, will just automatically download updates. So maybe Apple could just update the operating system as the FBI has requested, put a copy of the new operating system in the cloud on their servers, and just wait for the suspect's phone to connect automatically, as it probably does nightly or every 5 minutes or something, to pull down the new operating system. Now let's pause for just a moment. You probably don't want to do that for everyone in the world, otherwise we have an even bigger problem. Well, maybe the FBI might like to do that to everyone in the world, but probably won't go over so well. So just thinking sort of logically here, okay, is that possible? Is that a deal breaker? Can you roll out software to just one user in that scenario? How would you think?
You make it available only for that device's address.
Yeah, just for that device's address. And maybe that address is some numeric address. Maybe it's the device's phone number. Maybe it's the device's Apple ID, if you're familiar, like the email address that the human uses to log into that for automatic updates to the App Store. So there's probably a way to do that. So you have the operating system for everyone in the world, except for this one person who has his own version of the operating system getting pulled down. Now maybe it's not on the network, maybe that's a little easier said than done. So what's another mechanism? Well, it wasn't all that long ago that most of us here, Android or iPhone, were updating our phones via cable, some kind of USB cable connected to your Mac or PC, and that might very well be possible. And in fact, this is arguably a security flaw in the current version of iOS and iPhones more generally, that is in fact possible. You can update the software on the phone without unlocking the phone, it would seem. Now, why is that a security flaw? Because they have opened themselves to exactly this kind of request. So as an aside, the sort of outcome that seems inevitable from this whole process is there is no way that's going to be possible with the next version, you would think, of iOS, right? They could have deliberately tied their hands, Apple, so that this isn't even possible. Now, they've probably been assuming that because only they own the source code to iOS, that this isn't really a threat because no one's going to sit down and build their whole operating system and figure out how to install it on an iPhone. But it's certainly possible now to just require a passcode moving forward to install this operating system. So that's the gist of what they're asking. And the bigger picture that we can defer to perhaps a lunchtime style chat or dinner table style chat, the government suggests that this tool could be used only once on one phone. And that's where privacy defendants really bring some strength to bear. That just seems very unreasonable. As soon as the software actually exists, surely additional legal requests will come in. Surely there's a risk of some bad guy getting access to that kind of software, installing it him or herself on phones. And so you're just opening, it would seem, a can of worms. Now, even Obama recently, if you've read or listened to one of his recent speeches, commented, I think, that folks seem to be fetishizing their phones, so to speak, whereby we have accepted over 300 years the fact that the police, with a warrant hopefully, can come into your home or can search through the contents of your drawers or whatnot, and yet we seem to be putting a phone on this pedestal whereby it should be immune to all prying eyes. But I would argue, frankly, from a computer scientist perspective, that is actually progress. The fact that we now have the mathematical means to actually keep data truly secure by way of this thing called encryption that we'll come back to in just a little bit. So any questions about any of that just yet? Well, let me show you just how there is, in fact, one way to brute force your way into a phone. And in fact, this is not out of the question. This is just a short YouTube video of essentially a little robot someone built that does this with a little pad. And I forget what it is. This is using an Android phone because an Android phone, in this case, is vulnerable to this attack. It will not time out. It does not increase the delay between attempts. And so you can just do this, I think for like 3 days, I think was the caption in this video. After 3 days, this funny looking device will hack into an Android phone that has a 4, maybe it was a 6-digit passcode. So beware something like this if you see this on the table near you. This, though, is one mechanism. So what is Apple actually asking for? This article is a little longer, and it's the only other article we'll read today on paper or online. But let me invite you to take probably 4 or so minutes to take a look at the following. This is a longer URL here, but if you have the slides open in a tab, you can probably just copy and paste this from the slides themselves. And I have a printout here if you would prefer actually looking on paper. This is a more technical article that will offer us an opportunity to actually tease apart more technical jargon. and see what the authors actually mean. It's okay if you need to keep finishing up, but let me toss a question out there. Based on what you've read, are there any buzzwords, sentences, claims that we should first translate or distill that would make everything more straightforward? Anything at all? So if I started to pop quiz us on what certain sentences mean, we should be okay. Yeah. Oh, there we go. Okay. Oh, RAM. Okay. Yeah. Okay. So RAM. Let me define it first, and we'll come back to that point. Oh, what they're asking for there. Okay. So as a definition, RAM is random access memory. This is the type of memory that all of our computers have. It is distinct from a hard disk or a solid state disk. And a solid state disk or a hard disk is where your data is stored long term. So when you unplug the cord, even when your battery dies, any data or programs that you have on your hard drive or solid state drive remain there. RAM, meanwhile, is a type of memory that when you double-click an icon or open some file or run some program, it's copied from the hard drive or the solid state drive into RAM. RAM tends to be faster, albeit more expensive, and that's where files and programs live while they're being used. So we'll come back to the implications for that in just a moment. But for those unfamiliar, that's what that's all about. And phones have it as well. Any other definitions or clarifications we can make? All right, so the pop quiz is, what are the 3, at least, things that the FBI is specifically asking Apple for technically? One of them does indeed relate to RAM, so that's the spoiler there, and we'll come back to what that means. But what does the government want? Yeah, Chris, you want to give us one other?
I think the ability to electronically brute force the passwords.
Yeah, electronically brute force the passwords. And to, again, brute force, quick recap, what does brute forcing mean?
Try the number of combinations.
Again, exactly. Just try it again and again and again via brute force, not via intellect, not via cleverness. Just try every darn possibility. So the government wants a way to avoid brute force. They want a way to be able to brute force it electronically, and electronically as opposed to what? Manually. So as opposed to an FBI agent physically typing things in, and as opposed to silly-looking devices like the one we just saw, sort of automatically punching them in, they presumably want to do this wirelessly. And in fact, if you read the government's request, the court document, like via Bluetooth, Wi-Fi, whatever is possible, or maybe via lightning cable that plugs into the phone itself, that would be connected via USB to some hacking device that they have. So they want the ability to brute force the phone electronically so that they can just do it faster than a human or a robot could do it. They want somehow RAM. Let me read that sentence. It wants Apple to design this crippled software, the new operating system, to be loaded into memory, aka RAM, instead of on disk, so that the data on the phone remains forensically sound and won't be altered. So it's not clear to us, the readers, if exactly where the data is stored and where the operating system is stored, but presumably as a matter of principle and law, the government doesn't want to risk mutating any of the bits, any of the zeros and ones, or the data on the drive by putting a new operating system onto the hard disk itself, lest that open them up to a claim that, wait a minute, that file wasn't previously there when the suspect owned the phone. Rather, they want to put the operating system in RAM, random access memory, which is this faster place that is distinct physically from the actual hard disk. Of course, the operating system doesn't typically go there in its entirety, so that's a non-trivial request. So we've got this RAM request, we've got this brute force request, and one other at least. What else is the government asking for, Ben? Yeah, remove that timing delay, which in this case is how many seconds or milliseconds or 80 milliseconds, which sounds pretty fast. I mean, most humans can only notice delays of 100, 200 milliseconds and before something actually feels slow. But 80 milliseconds is roughly 100 milliseconds, and 1,000 milliseconds is a second. So that's like you can do 10 attempts per second, give or take. So that feels pretty fast, but not nearly fast enough if you've got a 6-digit code. And in fact, the article makes mention of that too. So if you've got a 4-digit code, as we discussed before, you might have 1, 2, 3, 4, and each of these numbers can be the number 0 through 9. So that's 10 possibilities times 10 possibilities times 10 possibilities times 10, and this is where we got that 10,000 from. if you have a 6-digit code, you of course just add this here, which is another 10, and another 10, which means we can just add another 0, and now we're up to 1,000,000 possibilities. So as an engineer, if 6 is too few, 1,000,000, that still feels relatively low, especially if you can do 10 per second. I mean, it gets a little boring, but you can do it by a brute force. What might be better than a 6-digit passcode? What's better?
Digits or letters and different combinations.
Yeah, so let's take both of those in turn. So slightly better than a 6-digit passcode might be, of course, a 7-digit passcode, which gives us 10,000,000 possibilities and just an additional digit. Better than that, though, would be an 8-digit passcode, 9-digit passcode, 10-digit passcode. But push back now. Now you're not the engineer, the security person. Now you're the product manager or the marketing person. Why is a 7-digit passcode not better than a 6-digit passcode for some definition of better? Yeah, it takes longer for the user, right? It takes an additional click, and slightly more compellingly too, I would say, is what? Yeah, it's slightly harder to remember the longer and longer it gets. I mean, we humans, at least in the US, have kind of maxed out at like 10 digits for phone numbers, and even that, I know like 3 people's phone numbers these days, so that's kind of a wash. So there's a point where it's just not a good user experience, or UX would be the trendy way of saying that. So what's better than just using digits? Well, instead of 10 possibilities, why don't we just get more clever, and instead of using 10 digits, 0 through 9, how else could we make a 6-digit passcode, a 6-symbol passcode more secure? What did you propose? Letters. So instead of maybe digits, why don't we just do letters like 26 times 26 times 26? And wow, this is actually getting pretty big fast. So if I go here, this is just my little calculator, and if I do 10 times 10 times 10 times 10 times 10 times 10, that's where we got the 1,000,000 possibilities from for a 6-digit passcode. But if instead we're doing 26 times 26 times 26 times another 26, 26, 26, this is now giving us 308,000,000 possibilities. And is that reasonable to switch from numbers to letters and still have it 6 digits? This means you need a 6-letter word. Most of us could probably remember a 6-digit English or some other language word. That's pretty reasonable. But we don't need to restrict ourselves to just letters. Why don't I get a little more ambitious? What might be slightly better than letters here? Be the engineer proposing an even better solution. A combination, characters. So not just 26 letters, but you know what? If I add back those numbers from before, well, everything's going wrong. That's 36. That's still 26. That's 36 times 36 times, and so forth. So that's getting bigger. How much bigger can we get this address space, as someone might say? What else could you add in besides letters and numbers? I'm up to 36. I'm 26, A through Z. Yeah, so we can really go crazy with the keyboard. Or even more simply, we can keep it simpler. Yeah. If we go uppercase and lowercase, now I have 26 plus 26, so that's 52 already, plus another 10, that's 62. And just to see the implications of this now, let's just do another bit of math. So 62 times 62 times 62 times 62 times 62 times 62. That now is giving me 56 billion possibilities. And it's still kind of reasonable. Could a human remember a 6 symbol, where a symbol is just a letter or a number, character password? Yeah, probably. That doesn't feel all that unreasonable. So what more can we add in? And as an aside, has anyone here ever heard the phrase base 64? Base 64? So we'll come back to this tomorrow when we talk about representation. Long story short, all of us humans in the room most likely understand base 10, the so-called decimal system. And all of us in this room count using 0s through 9s. We're going to see tomorrow in more detail that a computer counts using only 0s and 1s, the so-called binary system. So decimal is 10, binary is 2. Turns out there's also base 64, for which there isn't, to my knowledge, a really fancy word. But that means that you have not 0 through 1, or 0 through 9, you essentially have 0 through 64, but you use letters in that mix. And so we'll actually see that the means by which computers, for instance, attach files in an email these days is, an email, of course, might have an image on it, maybe even a sound or a movie file, but email is just text. it turns out that you can represent things like music and text, music and videos and pictures and the like as text using something called base64, where you use not only lowercase letters and uppercase letters and numbers, but also the underscore character and the slash on a keyboard. So more on that to come. So this is just getting really big. And now, as the security researcher, how could you make a passcode even more secure? We're now using lowercase letters, uppercase letters, and numbers. And you proposed, Victoria, just a moment ago, dots or symbols, and now we're really just kind of getting crazy. We're using all of the keys on the keyboard, and let me estimate that there are 128, give or take, possibilities on a typical keyboard, depending on your language and such, and there might even be more than that. So now let's still assume that we're only using a 6-digit passcode, and that's why I have 6 of those 128s. Let's see if I can pronounce this now. All right, so that's millions, billions, 4 quadrillion possibilities, if I counted this correctly. 4 quadrillion. Let me just double check, lest I be exaggerating our security. So that's hundreds of thousands, millions, trillions. I overestimated by a factor of 1,000. My apologies. 4 trillion possibilities. So that's more secure, right? Especially when we began this discussion with 1 out of 10,000 possible codes. Now we're up to 4 trillion. Now, does this mean a phone is secure if it is using a passcode that is 6 characters long, each of which can be a number or a letter or some funky symbol on the keyboard? Is a phone secure now, if this is in fact what the suspect was using? Yeah, and that's a perfect answer. You sort of conditionally explain that by reasonable standards, probabilistically, you're not going to get into this phone anytime soon. However, there is a chance, if small chance, 1 out of 4 trillion, that you might actually get the answer right on the first time. And the reality is, too, that if this suspect is like most humans, probably many of us in this room, he probably did not choose some crazy password with funky symbols on the key, because why? I mean, most of us wouldn't remember something that's so funky as that. And so it probably is maybe someone's birth date or some word or some phrase or something more memorable. So it's probably not even as secure as it might be mathematically. So where does this leave things? It sort of remains to be seen what Apple is going to agree to here. But it certainly has implications more broadly for society. But the takeaways for today are not so much the legalities, not so much the ethics or any of that, but really the understanding of what's actually going on. And when you read something like this, to sort of think to yourself, is this an author just using buzzwords? Is there actually technical meat to this comment? And what might I go and Google in this case? And in fact, probably one of the more technical things in here was this mention of RAM or memory. And that was simply for, presumably, the legal issue to which they allude. Secure enclave is, I think, Kareem, you mentioned earlier, this idea of exponential back-off, so to speak, or I put those words in your mouth. And that's a feature not in this phone. It apparently just has the 82nd millisecond delay, so it doesn't get worse and worse and worse over time. All right. Any questions? Yeah, Dan.
If you don't mind me asking, where do you stand on the issue?
No, I would side absolutely with Apple. I think math is not something that you should poke holes in, and I think the reality is, as even this article cites, you can poke holes in the iPhone, you can poke holes in the Android, but there will always be some alternative that a particularly smart adversary can use. So these kinds of measures really just protect us against the dummies, the lesser adversaries, which has value, but the reality is a determined adversary will absolutely keep encrypting his or her data via some other mechanism, whether it's via a mobile application, a desktop application. I think this is inevitable, and I also think this is a good thing as a matter of principle.
My question is, at the end of the day, there is one guy who can access everything.
Yeah.
So isn't it easy for FBI instead of or somebody else, instead of as a company, to negotiate with a person?
Yeah. And I think especially in this country, at least, where there were the recent revelations as to just how far the NSA has been going, that I, especially nowadays, don't buy the argument that we'll just use it in this particular case. I think that sets a bad precedent. And already there's a fundamental sort of paranoia we should have. I mean, all of us, like chumps, if you will, are walking around with cameras and microphones and GPS responders in our pockets willingly, telling someone potentially, even if it's just Apple or just Google, where we are at all times. And there really is nothing stopping Apple or some malicious engineer at Apple from somehow embedding in iOS a feature that only turns on David Malin's microphone 24/7 and sends that data up to Apple. And in fact, an interesting side note here is this is kind of sort of already happening as a feature. If you read the news about a year ago, Samsung started, rightfully so, to take some flack in the press because they have these smart TVs where, as best I can tell, smart TV really just means TV with bad user interface. But a smart TV, as a function of hardware, typically has like a microphone and a camera these days. And why? Why does a TV need a microphone or a camera? Skype, so which is reasonable if you want to use it in a conference room or at home for video conferencing. Pretty reasonable, pretty compelling. Voice commands, if you want to say change channel, lower volume, raise volume, turn off, that's not unreasonable, a la Siri and Google Now and such. Why else? Yeah, I mean, so that's what the paranoid in us might say. And the reality is, whether by a bug or deliberate intent, this is absolutely possible. Let's give them some credit. Why might you, as a user, actually want a camera in your TV? Or what's the proposed feature there? What's the camera? Why is there a camera like in your living room or in your bedroom staring down at you all? Okay, security. So you could argue that. In this case, it's not so much the consumer TVs that are in the business of security. In this case, it's because of a purported feature. Why is there a camera in a TV?
Video games detecting.
Okay. Yeah, closer. And some TVs probably do that, have built-in games. This, and I frankly think this is a little stupid, gesture control. I mean, I think stupid insofar as I don't really think we're there yet where we're living in the Jetsons where it just kind of works. Now I think you probably look like an idiot to your TV when it doesn't work. But gesture control, whereby the world is getting better incrementally, a la Xbox Connect, if you're familiar with the video game system, of being able to detect motion. So maybe this means lower the volume, this means raise the volume, maybe this means swipe left to change channels, swipe right to change channels. This is one of the reasons, this is the purported reason that they have the thing in there. But what Samsung took some flack for just a few months ago was that if you read their privacy policy, which no one, of course, is going to do, they encourage you in their privacy policy not to have private conversations in the vicinity of your TV. And we laugh, but like it's actually there, and that is because in order to implement this feature, the TV is always listening. It has to be, or it's always watching. And even if you have some defense mechanism in place, kind of like Siri, where you have to say, "Hey Siri," or "Okay Google," or whatever, the TV still has to be listening 24/7 for you to say, "Hey Siri," or "Okay Google." So hopefully that's all staying local, and there's no technical reason why it couldn't stay local, software updates aside. But in reality, very often Siri and Google alike are sending these data to the cloud, so to speak, where they get processed there by smarter, faster, constantly updated computers, and then send the responses back down to the TV. And the fun thing here, we took a look at this for another class I teach. We'll see this a little later today. There's something in the world called security and encryption, which we're getting to right now. And in theory, there's something called HTTP and HTTPS, the latter of which is secure. The S is for secure, and we'll come back to that. And they operate on something called different ports, different numeric values inside of a computer. It signifies if this is secure or not secure typically. Samsung, I believe in this case, was using the secure port, so to speak. They were using the secure address, but they were using it to send unencrypted data. So some security researchers essentially connected a device to their TV and realized when they spoke commands to their TV, it was being uploaded to the cloud through the correct channel, so to speak, but completely unencrypted, which meant anyone in the vicinity or anyone on the internet between points A and B could be seeing and listening to your voice commands from your living room or your bedroom. So there too, not only are we vulnerable potentially to maliciousness, also just stupidity and bugs in this case. So these are the kinds of things to beware. And again, the goals for today and tomorrow are to understand not necessarily how you would implement that underneath the hood, but to just reason backwards. All right, if my TV is responding to gesture control and my words, I'm guessing my TV is not so sophisticated as to have the entire English or the entire Spanish or whatever language I speak dictionary built into it, constantly updated. It's probably easier just to send those commands up to some server, Google or Apple or Samsung or the like, and indeed that's what's typically happening. So mind what you say in front of your TVs starting tonight, perhaps. All right, so That leads us then to encryption with a more technical look. And we won't go too deep a dive into this, but this article we looked at did mention something called AES, Advanced Encryption Standard is what it stands for. And it made mention of something juicy, a 256-bit AES key, secret key. And I'll just pull it up if you're curious to see where it was. It was in the, how would they do that? So somewhere inside of an iPhone and an Android phone, presumably, is some kind of secret key. And it's this secret key that keeps data secure. And in fact, have any of you in your iPhones ever gone to like settings, I think settings, maybe general, and then erase iPhone? It's somewhere under settings. You can erase your iPhone. And it tells you that you're going to erase it securely. Now, what does it mean typically to erase a phone or a computer securely? And actually, let me see if I can give you just a quick screenshot. We can probably find this. So iPhone, erase securely, settings, screenshot. Let's see if we can just find a quick photo. iCloud, erase data. That's not, here it is. So this is the screen I was thinking of. You can generally on an iPhone navigate to a screen that looks like this. And erase all content in settings. If you click that, it tells you it's going to do it securely. What does securely mean in a phone or a computer? Ben?
In a way that's difficult to then go back and actually find what you erased.
Good. So in a way that's difficult to go back and find what you've erased. So erasing it truly means erasing it. And the industry does not have a good history with this. Back in the day, most of us probably had PCs in some form. Some of you still might. And back in the day, when we still had floppy disks and certain other media, it was very common to run a format command or an erase command or a partition command, which were all generally related to getting a drive, a disk, ready for use. And back in the day, I can even visualize it now, the DOS, if you're familiar, the black and white prompt in Windows or even before Windows would yell at you in all capital letters, all data will be destroyed or all data will be erased. Complete lie. It was a complete technical and actual lie, because typically what a computer does, even to this day in most contexts, is that when you drag a file to your recycle bin or to your trash can on Mac OS or Windows or whatnot, we all probably know that it hasn't actually been deleted yet, right? You have to actually do what? To actually delete a file. You have to empty the trash can or empty the recycle bin. We've all kind of been taught that, and that's kind of the mental model we have in the real world. That is also a lie. Almost always, by default these days, when you empty your trash or empty your recycle bin, even by going to the right menu option or right-clicking or control-clicking and following good human intuition, it's a lie. All the computer is doing is forgetting your file. In other words, somewhere inside of your computer, you can think of there as being like a big cheat sheet, a big Excel file, a big kind of table with rows and columns that says a file called resume.doc is at this location on my hard drive, and a file called friends.txt is in this location, and profilephoto.jpg is at this location in my hard drive. So a whole bunch of file names, whole bunch of physical locations inside of your computer. And when a computer erases a file, typically all it does is it kind of deletes that row or crosses that out. It leaves the file on the disk. It just forgets where it is. And that's useful because if it's forgotten where it is, it can reuse that space later on. It can just put another file on top of it. And tomorrow, again, we'll talk about zeros and ones. That just means changing some zeros to ones, some ones to zeros, leaving some alone, but generally reconstituting a file out of bits, zeros and ones. So what is this actually doing? Thankfully, in iOS's case, since Apple actually is quite good at security, even on Mac OS, erasing your files does in fact do it securely. But how? Well, in Mac OS and in Windows, if you have the right software, what it will to erase something securely does have some technical meaning. And again, we'll come back to this in more detail tomorrow, but to erase a file securely does mean doing something to it so it can't be recovered. But what does that mean? Well, if a file, for today's purposes, is represented with zeros and ones somehow, I have no idea how, more on that tomorrow, but zeros and ones, the way you erase a file securely is you maybe change all of those zeros and ones to just all zeros, or just all ones. Like you completely, or just scramble them up completely randomly so that if someone thereafter looks at those zeros and ones, it's meaningless. And it's not recoverable because you did it randomly or you made them all zeros or all ones. That's not actually what Apple does. Because it turns out when you erased your iPhone, it doesn't take all that long. No, in fact, if you erase a computer hard drive, it might take an hour. It might take 3 days to literally change every 0 and 1 to some other value. There's just a lot of bits these days, especially if you have a hard drive that's 1 terabyte, so to speak. 4 terabytes will take a really long time. But Apple does it within a few seconds, maybe a couple minutes, but reasonably quickly. Now, why is that? It all relates to the same discussion. Apple, by default, keeps all of the data on your phone encrypted, scrambled in some way. And so to erase a phone, you don't necessarily have to change the data, because a general principle of encryption, the art of scrambling information, or cryptography, as the science itself is called, is that to an adversary looking at encrypted data, it should look random. He or she should not be able to glean any insights. They should not be able to realize, this person seems to use the word the a lot just because I see some pattern emerging again and again. It should look completely random statistically to an adversary. So by that logic, when Apple allows you to erase all content in settings, the data already looks random to any person on the street who might look at your phone's data. So they don't have to change your data. All they have to do to erase your phone is do what, do you think? Yeah, well, you could do, yes. Physically, they could just like type your code in 7777 10 times incorrectly. But rather, you can just forget the secret key. So encryption is all about having generally some secrets. So much like you can't get into a bank vault without a combination, much like you can't get into your front door without a physical key, you can't get into your hotel room without like one of those magnetic cards or such. In theory, there's something special, something that only you know or have that allows you access to some secure resource. In the case of your phone, it's the 4-digit code. In the case of your hotel, it's the little card key. In the case of your home, it's the physical key. Any number of things can be a key. But in computing, it's almost always a number, where a number is just a sequence of bits. And again, a bit is just a 0 or 1, but more on that tomorrow. So when Apple claims to be using 256-bit AES secret key, that just means that the secret key inside of your computer is something like 1011001100. I'm making this up as we go, and I won't bother writing out 256 possible zeros and ones. And we'll see tomorrow how this maps to an actual number. But for now, just know it's a really long pattern of zeros and ones. And that secret, that's like a really big magnetic card key for your hotel room that only you have. Or it's like a really special metal key with lots of little teeth that only you have. How is this useful? How is it useful to use a key? Well, let's do this. Let's start with truly a clean slate. And let me propose, just as a little experiment here for, say, a moment, how about we take the word hello, and suppose that you're back in middle school and you want to send the boy or girl across the aisle that you have a crush on a secret message, hello, but you don't want to be embarrassed if the teacher picks up the scrap of paper that intercepts the note that you're passing to him or her. You want to encrypt this information. You want to scramble it so it just looks like you're writing nonsense. And probably it's something juicier than hello, but we'll just take the word hello. How could we go about encrypting this message between the two little kids on a piece of paper? What should he or she write instead of hello? What's that? The number of letter in the alphabet. So, okay, so if it's A, B, C, D, E, F, G, H, I could maybe do something like 8 for that, and A, B, C, D, E, and I can do 5 for that. And similarly, I can just come up with a numeric mapping that would presumably just confuse the teacher, and he or she probably doesn't have enough, doesn't care enough to actually figure out what it is. So let's consider, though, is it secure? Why not? Yeah, if they are really interested, and if they have more numbers to go with than just 5, if there's like a whole paragraph, and it just so happens that all the numbers are between 1 and 26, that's kind of an interesting clue, and you could kind of brute force that. Let's see if A is 1, and B is 2, and C is 3, and if not, maybe let's try some other pairing. But a determined teacher, an adversarial teacher, could certainly figure this out. So what else could we do? A simple encoding, and this truly is called a code, not to be confused with programming code or programming languages, a code. And in fact, if you recall stories from yesteryear, especially in the military, a code book. A code book might literally be a physical book that's got two columns. One is a letter, one is a number, or some other such symbol that just maps to the other. And a code is a mapping from one thing to another. So that would be a code. Encryption, though, or a cipher, as you might say, is more of an algorithm. It's a process. It's not just something you look up. You have to kind of apply some logic to apply encryption, or a cipher in this case. So what's slightly more sophisticated, do you think, than that? What else could we do to send the word hello semi-secretly? Okay, so we could write it backwards. So we could do something like OLLEH or such, and it starts to look a little more complicated. So it's kind of scrambled, and you have to know the secret, and the secret is backwards or reverse or some sort of mechanism there. But that is an algorithm. That is a process where you have to move this letter over here, this letter over here, this letter over here, and you have to repeat it again and again. And we'll see tomorrow that this repetition is something called a loop, which is fairly intuitive, but it's very common in computer programming. What else might we do? Ah, very nice. So we could do something like, in increase, you mean like H becomes I? And let me keep it simple for the moment. Maybe E becomes F, and this becomes M, and this is P. Now, I'm kind of liking this, because now it doesn't jump out at you what has happened, and it looks like nonsense, but in terms of the security of this cipher, and the cipher here is kind of like a +1 algorithm. I'm just adding one letter to each of my own letters. And just as a corner case, what should I do if I hit Z? Yeah, probably just go back to A. But what if I want an exclamation point? Well, we'll have to come back to that sometime. So there's some corner cases, so to speak, things you need to anticipate if you want to support those features. But what is attackable about this? It's obviously not that secure, because we sort of thought of it and wrote it down super fast, so presumably a smart adversary could do the opposite. But what information is leaked in this particular ciphertext? Computer scientists would call this clear text, and this ciphertext. Ciphertext meaning just scrambled or encrypted. We're leaking information, so to speak, with this ciphertext. I know something about the original word right now. Same number of letters, so that's leaking information. I have sent my crush a 5-letter word, it would seem. And what else?
Yeah, there are letters.
Letters. There's still letters.
Third and fourth characters.
Yeah, the third and fourth letters repeat, and this is very common. This realization for what's called a frequency analysis. And I used the word the, kind of anticipating this earlier. The is a very common English word. And so if we actually had like a paragraph or a whole essay that was somehow encrypted, and I kept seeing the same patterns of 3 letters, not THE, but like XYZ or something like that, I might just guess on a hunch, based on the popularity of the in English, that, you know what, maybe I should start replacing every XYZ with THE, respectively, and you kind of chip away at the problem. And in fact, if you've ever seen a movie about like cryptographers, especially during military times, cracking codes, a lot of it is this sort of trial and error and leveraging assumptions and taking guesses and seeing where it goes. And in fact, all right, we sometimes see in English words, so maybe this is unchanged. We see EE, we see OO, we see LL. We don't really see like YX, and there's bunches of others I could probably contrive that we never see, so we've narrowed our search space, so to speak. In other words, if the problem initially feels this big, as soon as you start ruling out possibilities or ruling in possibilities, it starts to get a little more tenable, a little more solvable. And in fact, this is an example actually of something called a Caesar cipher, where a Caesar cipher is a rotational cipher where one letter becomes another, and you just add uniformly the same number of changes to each letters. And Dan actually hinted at something slightly more sophisticated earlier, which we might add, for instance, 1 letter to the first letter, EF. Maybe this becomes G, 2 away. Maybe this becomes M and O. This time it becomes P, and then so forth. We add incrementing values to each of the letters, which is harder because now notice LL does not look like MM anymore. We now need to be a little fancier. And this is what's called, after a French guy, a Vigenère cipher. where you're using disparate keys, different values. And in fact, let's tie that back together. We used the word key before, both in the physical sense for like hotels and homes, but in the electronic sense, a key is just a secret value, typically. And a secret value in this earlier case, IFMMP, what is the secret key I'm using for this cipher that Dan proposed earlier? Yeah, the key is just the number 1. Not the most secure, but it's simple. But all of these security mechanisms require what? That not only I know the secret is 1, but also what? Who else has to know it? The recipient has to know it. And just for clarity, who must not know it? The teacher, right? Unless he or she has the time and energy to brute force it or figure it out. So super simple idea, but it maps to what you're reading about and hearing about every day in the news. But the 256, this is essentially 1 bit. 256 bits is much bigger. And again, we'll get a quantitative sense of that tomorrow. Any questions then on Apple, security, encryption, and these building blocks? All right, well, yeah. Ramon?
This organized in an organization like Apple, do you have any insights there? How many people know about these security codes and this thing?
Oh, it's a good question. I don't know internally, in Apple, of all companies, is particularly quiet when it comes to those kinds of implementation details. But I can say more generally, a fundamental tenet of security, at least in the academic community, is that you should never have what's called security through obscurity. You should never do something to protect data or users or information whose security and privacy is all grounded on no one knowing how it works. In other words, what the article alludes to, AES, Advanced Encryption Standard, that is actually a global public standard that you can open up a math book or go on Wikipedia and actually read what the algorithm is. And much like the algorithm here is the super simple +1, this is more complicated mathematics, but it's public knowledge. And this has a number of upsides. 1, it means anyone can use it and implement it. But 2, it also means that millions of smart people can review it and make sure to speak up if it's flawed in some way. And so, in fact, one of the best defenses against governmental backdoors, whether this country or any other, is to just publicly discuss these kinds of algorithms, because it's very unlikely that the entire world of academic researchers is going to collude and actually tolerate hidden backdoors in algorithms like that. However, you do need to keep something secret. And so just to be clear, when you're using a cipher like AES, or something like Caesar or Visionaire that we alluded to there, what does have to be kept secret? Not the algorithm, not the process, the code, right? And the key, to be clear. And so to be super clear, even though this is a trivial example, the cipher or algorithm that we've generally been using in this discussion is this thing here, the plus. So addition is our super simple cipher or algorithm. AES would be a much more complex equivalent of the plus. You do a lot more math, a lot more additions, multiplications, and so forth. But the key is not the same as the cipher. In this case, it's also super simple, just the number 1. In Apple's case, it's some 256-bit pattern of zeros and ones. So I'm not really answering your own question because I can't really speak to what Apple knows, but the Apple engineers have disclosed that they implement this algorithm. To some extent, we have to trust that they're being true, and we have to trust that they didn't nonetheless build in some secret backdoor for the NSA, and that's fundamentally hard to do. In fact, the frightening thought I can leave you with on this particular subject is, much as we might all talk about this, and much as Tim Cook might assure us that these phones do not already do what the FBI wants them to do, it's nearly impossible to verify or audit as much, right? Do you even know that my camera is not on right now? Do you know that your own MacBook's camera is not on right now? Well, most of you might know intuitively or from experience, well, if the green light's off, what does that mean? It's not on. Okay, you've been taught that, but why couldn't you write software that turns off the light but turns on the camera? There's really no fundamental defense against something like that. So even we humans can be socially engineered by our computers to sort of trust one reality when really we can then be taken advantage of because of that exact same assumption that a green light means the camera's on. That's not necessarily true. Yeah, so actually I always kind of smile, but I appreciate it when you see real diehards around campus. Or do you have tape on your? Okay. So putting tape on it is a more surefire thing. Of course, there's still a microphone that you can't really tape over as effectively, but these are the kinds of trade-offs. And in fact, one takeaway hopefully for today should be absolute terror when it comes to these kinds of things, because at the end of the day, we have to trust someone. And that, too, is a fundamental tenet of security. Ultimately, you have to trust someone. You have to trust that the person you have a crush on is not going to tell his or her best friend what that secret code is and then disclose that same information that you're trying to keep secret. All right, let's take a look. Yeah, Dan.
What does the acronym CBC stand for as it relates to AES?
Oh, CBC is block. What does it stand for? Blockchain, CBC. I forget what the acronym stands. Cipher block chaining. Okay, so cipher block chaining is an acronym that refers to, I believe, the process of what goes on inside of an algorithm, for cryptography in this case, whereby it's iterative. You do something again and again and again, and you take a previous output and feed it into your process as a subsequent input. So you keep feeding the results back into themselves. And an analog here might be, I should be able to come up with a good metaphor here. Let me try to think of a better example here. But let's see if we can come up with a quick picture. Let's see if Wikipedia gives us a picture that would explain. No, that's not good. OK, this is a more pictorial complexity than we really want. But the idea here is that if you are enciphering something, it gets fed in, then the output gets fed in again, then gets fed in again, so that you're iteratively scrambling information using previous output as a subsequent input. Let me see if I can come up with a better explanation. Give me lunchtime to noodle on that one. All right, let's come back here. Oh, and I'll encourage you, your only homework for tonight, if you'd like, and you haven't seen, is to watch a 20-minute video if you have internet access and go on YouTube. Last Week Tonight is a brilliant show by John Oliver, formerly of The Daily Show. And at this URL here, you can actually look at his humorous but simultaneously serious look at this same issue. And hopefully even more of that video will make sense. And this is in the slides too. So if you have the URL up with the slides, this is here too. And we'll get you online during the break as well. So in our concluding minutes, let's take a quick look at one other example of a technology that's ever present these days, file sharing, both in consumer and in corporate contexts. And that is by way of, for our purposes, something called Dropbox. All right, so for those unfamiliar, in a sentence or two, what problem does Dropbox solve? Yeah, exactly. It allows you to share files often with yourself, so that if you do have an iPhone, an Android phone, a Mac, a PC, multiple Macs, multiple PCs, home computers, work computers, you can have a folder that in turn has its own subfolders that automatically get synchronized across all your devices. And it's wonderfully useful. For instance, in the morning, if I'm preparing for class, I might get my slides or videos or pictures ready, drop them in a folder on a home computer, then walk to school and open up a work computer here, and voila, it's magically there. Unless I screwed up, which has happened sometimes, and there's nothing more stressful than having done all that work hours prior, and you have nothing to show for it when it comes time for class. So it fails sometimes, or the human fails, but in theory, that's exactly what it's supposed to do. More compellingly for other users is that I can very often then control click or right click a folder or file that I'm using with this service, and I can send a URL that results from that click to a friend, and he or she can then download a copy of that file. Or better yet, we can share folders so that if I make a change, then Victoria can see my changes in her folder, and Kareem later in the day can edit and see that same file and folder as well. So there's a lot of implications here, and we'll just scratch the surface and try here to spook you a bit into not taking for granted how all this works and what the actual implications are for things that you're using. In particular, let's consider how Dropbox must surely work. So if I'm over here, let's draw a quick picture of me. If this is little old me, this is little old me on my laptop here. And let's say this is Victoria with her tape on her camera. And here we have Kareem with his laptop here. And then somewhere is this thing called the cloud. More on that this afternoon as well. So how does Dropbox work? Suppose I create a folder on my computer and I install this software called Dropbox, but we could also be talking about OneDrive from Microsoft, or we could talk about Google Drive, or any number of other products. It's all sort of fundamentally the same. If I've got a folder called Dropbox on this computer, and I've just created a PowerPoint presentation or an Excel file or an essay, and I drag it into that folder, what must happen in order to get it to Victoria's computer or Kareem's computer? Yeah, so somewhere in here, there's a company, and we'll call this Dropbox. And this is David, this is Victoria, and this is Kareem here. So somehow, I must have an internet connection that leads to the internet, more on that after our break, that gets stored on servers in Dropbox's headquarters or data center, wherever it is. And then Victoria's computer and Kareem's computer get that data how? Have to, say again? Yeah, I have to share with them. So I have to have sent Kareem and Victoria a URL, or I have to like click some menu option and type in their email address so that it automatically gets shared. Let's suppose I've done that. What then happens in terms of this picture?
You need a user account and a way to authenticate.
Yeah, we're going to need a priori some kind of user account. So I've got to register for Dropbox. Each of you probably has to register for Dropbox, at least in this scenario. But then ultimately, that file gets transmitted down in this direction just as it went up from my direction there. Similarly, if we've used a certain feature of Dropbox, you can either make copies of files or actually share the originals. If you guys start to make copies, then in theory, those should propagate back to me. So if you're a particularly paranoid user, or you're the CTO or chief security officer at a company, what kinds of questions should you be asking here about this whole process? Yeah, OK. So I am now the head of Dropbox. Yes, we use industry standard encryption to secure your data. Satisfied? Why not? OK, I'll be more specific. I use 256-bit AES encryption just like our friends at Apple do.
But all that data exists on all those machines, and all those machines are vulnerability.
OK, true. So suppose there's a whole bunch of servers in Dropbox's headquarters or data center, or all of their data centers, and it's the data, and this is a feature, is replicated, copied across multiple servers. Because God forbid one computer or one hard drive dies. These days, very common is to replicate data across at least 2 computers or 2 hard drives, sometimes as many as 5 or more, so that statistically, even though, yes, lightning might strike all of Dropbox's data centers simultaneously, or they might get physically attacked or compromised all at the same time, the probability of that happening is very, very, very low. So for all intents and purposes, my data is backed up safely. But it's encrypted, so what? Doesn't matter if every copy gets stolen. Doesn't matter if the data center gets infiltrated. My data is still encrypted, so no one can see what it is. What questions should you continue asking?
Is it all encrypted the same way across
Ah.
every customer?
Embarrassingly, yes. We use the same key to encrypt all of our customers' data.
But then it's very easy to unencrypt, decrypt it.
It is, and that's a feature. We can do this super fast for you, which is why the files sync so quickly. We use the same encryption, the same key for everyone. It's a feature. And I said it sheepishly, and this actually, I believe, is still actually technically true. They do use the same secret key, whether it's 256 bits or more, for all customers' data. And this is partly for technical reasons. One, if I am sharing a file with Victoria and Kareem, and they want to be able to access it, I've got to somehow decrypt it for them. But I don't really have a mechanism to give Victoria and Kareem a secret key, right? If I email it to them, I'm compromising it, because anyone on the internet could intercept my email. I certainly am not going to call them with a sequence of 256 zeros and ones or more and tell them to type it in. It could just be a password, but I'd still have to call them. And in business, this isn't going to work very well. If you want to share a file with 30 people, I'm not going to make 30 darn phone calls, and I can't send out an email because that's insecure. So there's really this fundamental problem of sharing it. So you know what? It's just easier if Dropbox does the encryption for us. But if they do it for us, only they know the key. And if they reuse the key, that means that all of the data could be compromised if that key itself is compromised. Now, having asked at least one buddy at Dropbox, they do have, and I think they have white papers that testify to this fact, they do have very, very few people who have access to that key. The computers have to have it in memory, and it's got to be locked up in some vault somewhere so that, God forbid, the computers crash or need to be rebooted. Someone does have to type in that key at some point. So that is really the secret sauce, if there were any. But this definitely has implications for my data. It's disclosable if someone compromises that key or that data center. But it also allows Dropbox another feature. It turns out, and this is kind of a business cost, if you used a different key for every customer, or even more so for every file, mathematically, every file, when encrypted, would look different from every other file. So even if I had 2 copies of the same PowerPoint presentation on like Kareem's computer and on my computer, if those files were encrypted with different keys, the ciphertext, the scrambled thing, would look different. This is not a good thing because it doesn't let Dropbox realize that those files are the same, as we kind of discussed earlier. Why might Dropbox want to know when 2 users or more are sharing the exact same file? Why is that useful information for Dropbox from a business perspective? Space. PowerPoint presentation is not that big, but people commonly share big movie files, video files, maybe really big PowerPoint presentations. And if you have 2 users with the same file, or 10 users, or maybe 1 million users with the same popular illegally downloaded movie file, it's kind of wasteful to store 1 million copies of the same gigabyte of information, the same gigabyte-sized video. And so Dropbox, like a lot of companies, have a feature called deduplication. Deduplication, which is just a fancy way of saying store 1 copy of the same file, not multiple, and just keep track of the fact that 1 million people or whatever have that same file. So just point all 1 million people or so to that same file. And you still back it up a few times. So this is separate from the issue of redundancy in case you have hardware failures or the like. But deduplication requires that you not encrypt files individually if you want to be able to determine after the fact if they're still in fact the same. So there's some trade-offs here, and it's not necessarily clear what the right call is. Personally, with Dropbox, I'll use it for anything related to work, certainly anything related to class, certainly for any files that I know are going to end up on the internet anyway by choice. But I don't really use it for financial stuff, nothing particularly private or family related, because as a matter of principle, I'm not super comfortable with the fact that it might be encrypted on my own Mac, but as soon as it goes out to the cloud, it's on little old Dropbox's servers, and I'm pretty sure no one at Dropbox has it out for me and is going to go poking around my files. But they absolutely could, in theory, no matter what policies or defense mechanisms they put in place. It just must be technologically possible. And God forbid they are compromised. I'd rather my file not end up in some big zip that some hacker puts online for the whole world to see. So let's push back on that. What's a solution then? Could you continue using a service like Dropbox comfortably and assuage my kinds of concerns? Private cloud, what does that mean?
Well, you secure it somehow so that it's available only for a particular group of people.
Yeah, so you need to kind of partition the cloud into something a little more narrowly defined, and we'll talk about an intranet. So I could just back up locally to my own home backup server or cloud server, so to speak. Unfortunately, that means that Victoria and Kareem need to visit more often if I want to share files with them. But that might be one way. There are also third-party software that I could use on my Mac or my PC that encrypts the contents of a folder. But then I do have to call Victoria or Kareem or email them or something to tell them that secret. And that's a bit of a white lie because there are types of cryptography that do allow me and Kareem and me and Victoria to exchange secret messages without having to, in advance, share a private key, a secret key with each other. It's actually something called public key cryptography, and we won't go into technical detail, but whereas we today have been talking about secret key cryptography, where both sender and recipient have to know the same secret, there's something called public key cryptography, which has a public key and a private key, which, long story short, have a fancy mathematical relationship whereby if I want to send Victoria a secret message, I ask her for her public key, which by definition she can email me. She can post it on her website. It is meant mathematically to be public, but it has a relationship with another really big number called a private key, such that when I encrypt my message to her, hello, with her public key, you can perhaps guess what's the only key mathematically in the world that can decrypt my message. her private key or corresponding private key. It's fancier math than we've been talking about here. It's not just addition, certainly, but that too exists. And in fact, and we'll come back to this when we talk about the web and HTTPS, odds are you've never called someone at Amazon.com when you want to check out with your shopping cart and type in your credit card number, and yet somehow or other that padlock symbol is telling you your connection is secure. Somehow or other your little old Mac or PC does have an encrypted connection to Amazon, even though you've never arranged with them for a secret. And that's because the web is using public key cryptography. Well, why don't we pause here, take our 15-minute break after Olivier's question.
I just have a question.
No, not at all.
If you have the original file and the key is the same for Dropbox for everyone,
Mhm.
and you have the encrypted file, can you just retrieve the key?
Say that once more.
If you have the original file
Uh-huh.
and the encrypted file, and you have both of them, can't you just have a mechanism to retrieve the key and as it's the same key?
Oh, a good question. If you have the plain text and the ciphertext, can you infer the secret key? It depends on the cipher. Sometimes yes, sometimes no. It depends on how complex the actual algorithm is. But that does not help your situation. It is a fundamental tenet to, if you have access to the original file and the resulting file, you should no longer use that key because now you have leaked information, and an adversary could use that and exploit that to do what you're alluding to and reverse engineer what that key is. But in this case, presumably when you're sending something to the recipient, you already have a trust relationship with them, and so by definition they should have or know that key already. It's when someone in the middle gets in the way. Good question. All right, why don't we pause, take a 15-minute break. Restrooms are that way. I think there's probably some drinks and snacks that way. And we'll resume at 5 after 11. How about 11:05?